Next we are going to see the next property of DFT, that is nothing but the circular time shift of a sequence. Circular time shift of a sequence. What is the next property? Circular time shift of a sequence. Now you are considering a sequence x of n and its DFT, that is endpoint DFT is x of k, then x of n minus l, that is we are going to time shift a sequence by L samples, is nothing but that x of k into e to the power minus 2 pi k L by n. So in simple we can tell that the time shifting the sequence circularly by L sample is equivalent to multiplying its DFT by e to the power minus 2 pi kl by n. So what is this? This is nothing but time shifting a sequence. Okay, time shifting a sequence x of n by L sample, that is equivalent to multiplying its DFT by e to the power minus 2 pi kl by n. So this is a property. Then I am going to explain one concept. Now I am going to consider. So what is a property? If x of n is a sequence and its DFT is, that is endpoint DFT is x of k, then x of n minus L of n, that is time shifting a sequence by L samples, is equivalent to multiplying its DFT by e to the power minus j 2 pi L by n, kl by n, e to the power minus j 2 pi kl by n. Now so I am considering a endpoint sequence x of n. I am considering a endpoint sequence x of n. So this is x of n. This is n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7. So this is x is equal to x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So I am considering a sequence. Now what I am going to do means, the sequence is having 8 samples. Okay, these are the 8 samples: x naught, x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. These are the 8 samples. Now what I am going to do means, I am going to delay this sequence by 2 samples. I am going to delay by 2 samples. Okay, so L is equal to 2. I am going to delay by 2 samples. So delaying by 2 samples is nothing but shifting in the positive side, that is in the anti-clockwise side. So anti-clockwise side is called as positive. Okay, what I am going to do, I am going to delay this, or I am going to shift this sequence, or I am going to delay this sequence by two samples. So I am drawing this once again. So initially I am having x of 0 at this point. So now what I am going to do means I am going to shift it by two samples. Okay. So 1, 2. So here you'll be getting x of 0. Here x of 1. Here x of 2. Here x of 3. Here x of 4. X of 5. X of 6, x of 7. So I have delayed the sequence by 2, that is x of, this is x of n and this is x of n minus l. Okay, delayed by two samples. Now, so here initially you are having the x of 0 at this point. At this point you are having x of 0 at this point. Okay, so you have delayed by two samples. So actually we can split this area into two, that is from here to here one part, and we can from here to up to this point another part. Okay, you can split this into two part. This is the first part where you have delayed your sample by the sequence by two samples. Okay, so you can write this as summation of, usually how you will be writing this means summation of n is equal to 0 to n minus 1 x of n minus l into e to the power minus j 2 pi k n by, sorry, k small n by capital N. Okay, now this entire, this is nothing but the entire sequence. Now we are splitting this into two. How means, from first this one part, how many samples you have delayed? Two samples. So the here the value of L is nothing but 2. So we are writing as n is equal to 0. 0 is, this is n is equal to 0. 0 to 2 samples, L minus 1. Okay, this is 2. Now your 0 is coming to this point. So 0 to L minus 1 x of n minus L. So be careful, here you have to put double bracket. So why? Because here you are circularly convoluting by two samples, plus L2 summation of L is equal to, sorry, n is equal to L to n minus 1 x of n minus L into e to the power minus j 2 pi k n by n. Here also e to the power minus j 2 pi k n by n. Whether it is clear? Initially you are taking a sequence, then what you are doing? You are delaying a sequence by two samples. That is, it is shifted positive side by two samples. Now the entire summation that you are splitting into two part. First one is 0 to L minus 1 and L to n minus 1. Two part you are splitting. Now we are going for the proof. DFT of x of n minus L n is equal to, what is the expression for DFT? N is equal to 0 to n minus 1 x of n minus L n e to the power minus j 2 pi k n by n. Now already I have explained, I am going to split this summation into two, that is n is equal to 0 to L minus 1 x of n minus L. Be careful while writing the expression. Here you have to put double bracket, that is circularly convoluting by n times, n samples plus n is equal to L to n minus 1. L minus 1, n minus 1 into x of n minus L. Here there is no double bracket. E to the power minus j 2 pi k n by n. Sorry, here also you will be getting this e to the power j 2 pi k n by n. So what you will be getting, I am writing it once more clearly. N is equal to 0 to L minus 1 x of n minus L. Here you have to put double bracket plus into e to the power minus 2 pi k n divided by n, j 2 pi k n divided by n plus n is equal to L to n minus 1. So wherever you are putting n, you put 1 like this, because you will be confused with L and 1. So x of n minus L into e to the power minus j 2 pi k n divided by n. First you take the first part. Now we are going to take the first part. This x of n minus L double bracket of n, that can be written as n is equal to 0 to L minus 1 x of n plus n minus L of e to the power minus j 2 pi k n by n. Okay. Now you take, first you consider the first part, we will simplify, then we will take the second part and we will simplify, then we will combine. So in this you take n plus n minus L is equal to m. Okay. Now in that you substitute n is equal to 0. When you substitute n is equal to 0, what you will be getting? N minus L is equal to n. So n is equal to 0, what you are getting? N minus L is equal to m. So when n is equal to L minus 1, what you will be getting? N plus L minus 1 minus L is equal to m, and this L and this L will cancel, and you will be getting m is equal to n minus 1. So here your limit gets varied. So limit will become m is equal to here the limit will become m is equal to n minus L to n minus L to n minus 1. So this 0 to 1 L minus 1 limit has changed to n minus L to n minus 1. So in the place of n plus n minus L, you have to put m. So what will be getting? X of m into e to the power, in the place of, here small n, here capital N. Okay. In the place of this small n, what you have to put? From this you calculate what is n. N is equal to m plus L minus n. So you'll be getting e to the power minus j 2 pi k by n into m plus L minus n. So we will go to the next slide. We will be writing what you are getting. Your limit has changed from m is equal to n minus L to n minus L to n minus 1 x of m into e to the power minus j 2 pi. What is your k by n of m plus L minus n. So this is what you are getting for the first part. Now what I am doing is m is equal to n minus L to n minus 1. So I am splitting e to the power a plus b is equal to e to the power a into a to the power b. So e to the power minus j 2 pi k by n into m into e to the power minus j 2 pi k L divided by n into e to the power j 2 pi k n divided by n. But e to the power j 2 pi k n divided by n will cancel and you will be getting e to the power j 2 pi k, that is cos 2 pi k plus j sin 2 pi k. So cos 2 pi k plus j sin 2 pi k is equal to 1. So instead of this you can put 1 and you will be getting m is equal to n minus L to n minus 1 into, so you are having x of m here. So x of m into e to the power minus j 2 pi k m by n into e to the power minus j 2 pi k L divided by n. So this is the first part. Okay, this is the first part, and now we are considering the second part. Actually, what is the second part? N is equal to L to n minus 1. Summation of second part is n is equal to L to n minus 1 x of n minus L into e to the power minus j 2 pi k n divided by n. This is the second part. Now here you take n minus L is equal to m. From this, what is n? N is equal to m plus L. Okay. Now here you put n is equal to L in this m, and you are putting n is equal to L, you are getting m is equal to 0. First one. When you are putting n is equal to n minus 1, n minus 1 minus L is equal to m, and this can be written as n minus L minus 1 is equal to m. So the limit is varying from m is equal to 0 to m is equal to n minus L minus 1. So in the place of n minus L, so here first we are changing the limit. So m is equal to 0 to n minus L minus 1 x of, instead of n minus L you are putting m of e to the power minus j 2 pi k by n into, in the place of n you are putting m plus L. Okay, m plus L. Now we are splitting the e to the power term. We are splitting the e to the power term. So we are getting x of m into e to the power minus j 2 pi k n into m into e to the power minus j 2 pi k L by n. Now we are going to combine the first and the second term. So what is the first term? M is equal to summation of m is equal to n minus L to n minus 1. e to the power j km by n, to the power j to the power j km by n into e to the power minus j 2 pi kl by n, plus the second term is m is equal to, what is the second term, 0 to n minus l minus 1 into e to the power minus j 2 pi km by n into e to the power minus j 2 pi kl by n. So finally we from these two terms I am taking e to the power minus j 2 pi kl by n common. So remaining what you are getting is m is equal to n minus l into 2n minus 1 x of m into e to the power minus 2 pi km by n plus m is equal to 0 to n minus l minus 1 x of m into e to the power minus j 2 pi km by n. Now you check this summation. So m is equal to, first you can rearrange this. You can write this term first and this term second. Then you will check the summation is starting from m is equal to 0 to n minus l minus 1. Second, it is starting from l minus 1 to n minus 1. So totally we can combine these two to m is equal to 0 to n minus 1. So we can write it as e to the power minus j 2 pi kl by n into summation of m is equal to 0 to n minus 1 of x of m e to the power minus 2 pi km by n. But what is summation of m is equal to 0 to n minus 1 x of m into e to the power minus 2 pi km by n? That is nothing but x of m. So we can write it as e to the power minus j 2 pi kl by n into x of k. So we can write it as DFT of x of n minus l, that is delaying a time sequence, is equal to multiplying the DFT by e to the power minus j 2 pi kl by n. So this is nothing but the circular time shift of a sequence or circular time shifting property. Okay.